Okay, we will explore the machine learning life cycle in today's session. So it is, the typical application development. You take any application development, any software development project, they follow the life cycle, software development life cycle, right? As part of the software development life cycle, if you see the first phase is the requirements gathering, and the last phase is the deployment. Okay, deploying your application on the production environment. Okay, afterwards you will be monitoring, support, everything will be done. The first phase of the software development lifecycle is requirements gathering. So when it comes to machine learning, it's a problem definition framework. So the software development lifecycle here also, right? What we do is we gather the requirements. We try to understand the customer's pain points. Okay. So here, the first step is we define a problem. Okay, the new problem to address with machine learning. So this one helps us to quickly understand the elements and motivation for the problem. And also it can help us whether machine learning is suitable or not in terms of solving the problem articulated by the business stakeholders. Okay, so as part of the problem definition, the first step is we understand what is the problem and why does the problem needs to be solved. And second step is how we are going to go ahead and solve the problem. That is what we do it as part of the problem statement. For example, you are working for a realtor and he wants to he wants to basically he wants to predict the housing price. Let's say you are working for a realtor in Mumbai, so you want to predict the price of houses in Mumbai, given some number of features. For example, the location, and given the location and the size of the house and the total square foot and number of bathrooms and bedrooms. Based on these factors, you want you to predict the housing price in Mumbai. Okay, so this is what the problem statement. So at present, they are not able to predict, based on some mathematical equation. They are all doing guesstimate. Okay, so based on some, based on the guesstimate, right? They are doing it, but with guesstimate, you cannot your predicted value will not be accurate all the time. So hence there will be some proper mathematical equation or algorithm. If you use it and make the prediction, we can make sure that the prediction accuracy is very reliable, and it is near close to the ground truth. Ground truth is the actual value. Okay, as part of the problem statement, we'll define so what we want to do. Okay, what is the problem, what we want to, why we need to initiate this project. As part of this project, this is the big picture. Basically, we wanted to predict the price of housing price in Mumbai, and some other scenario, like in some other cases, understand and predict product attributes that make a product most likely to be purchased. What factors which drives selling a specific product more in the market, right? So this is one of the requirement. And some other cases, right? How likely someone is click on an online ad. So you are an SEO expert, search engine optimization expert, and you do optimization everything. But somebody is asking you, right? So what are the chances, or what is the chances that the someone is going to click my ad in the online? So can you help me predict how many users are expected to click my ad? So these are the different problems posed by different department within a company, or different companies. They face different problems. To solve the problems, they come up with the problem statement. As part of the problem definition or problem statement, so as part of the problem statement, define the problem. Once they define the problem, and they will see if they can convert the problem statement into machine learning problem. That is the next step. So, and then what we do is we start extracting the data in order to create or build a machine learning model to predict the housing price in this case. Okay, and then what we do is, as part of extracting the data, we talk to the various stakeholders, and we will make sure that the source systems, right, the gold source, right? So they say the gold copy in the sense, so in my company we have 100 servers are there, of all those hundreds, which servers and which databases and which tables do I need to extract the data. Okay, so once you get to know the environment and once you extract all the necessary data, the next step is you start exploring the data. You conduct the exploratory data analysis. Okay, and this is the third phase. And the next one is data cleaning. Okay, and so now the question is, after extracting data, why do we need to do the exploratory data analysis? Probably after we do the data cleaning or feature encoding, can't we do? No, so before even you clean the data, right, you should be knowing how good the quality of the data. In order to, right, in order to understand that, you need to explore the data. So for example, use the box plot visual, and with that, you will be able to understand, okay, how many outliers are there in the given data set. Okay, and how do we address those outliers? And also, if you notice any missing values, and you come up with a strategy to perform the data imputation and so on. Okay, so unless you explore the data, how will you get to know the quality of the data? Whether the given data is sufficient enough to build the model or not, right? So before you perform the data engineering or the feature engineering or pre-processing, we explore the data to understand the quality of the data, and also we try to find out the patterns in the data. Okay, and the patterns in the sense insights. Okay, so you, by doing the exploratory data, you will get to know the insights by visualizing the charts also. Okay, okay, so now the next step is, after exploring the data, next step is you need to do data cleaning or scrubbing, and you need to do feature encoding as part of data pre-processing, and also you need to do this feature scaling. Okay, in today's session we will explore all the things. Okay, don't worry. And followed by this feature selection. After you do the feature scaling, feature encoding, data cleaning, everything, next step is you need to do the feature selection. What is feature selection? To take the subset of the columns, find out this best subset of the columns which can help predict your target outcome variable with higher accuracy. And those features that are not having predictive power, you can discard those features. So that is what we do it as part of feature selection. There are different techniques are available as part of feature selection. Okay, we will take a look at that also. And the next step is, after you do the feature selection, next step is you build and train your model. Okay, so right, so before you build and train the model, we have another step called choose the model. Okay, which model can I choose it? Okay, so it depends on the data that you have at your end. For example, in the case of a regression problem, you can go ahead with the linear regression, but you have a gradient boosted model is also available. With that, we can get higher accuracy. Even random forest model is available. Okay, so there are different types of models are available. So what we do is based on the root mean squared error. So which model error is less? Okay, so let's say the person A, person B, person C. I'm giving an Excel sheet to these three people. I just check of these three persons, which person's accuracy is more. The person, let's say the person B's accuracy is more. He estimated and he gave me the housing price. I could see the estimation accuracy is very high. That means the error is less. So that means the person B is good. So that's how we do the model selection. Whichever model has lesser error, which means higher accuracy, that is the best model, right? So we choose that model. And then what we do is, once you train the model, you evaluate the model. You train, apply the trained model on the tested data set, and then you do cross validation. Supposing the given data is not a huge one, so what you do is you do tenfold cross validation, and you check the bias and variance. If the bias and variance are reasonably okay, right? So then you are good to go ahead with deploy the model. So if you don't have any overfitting or underfitting issues, or in case of overfitting, let's say you are going to use an algorithm called the regularization algorithm. You try with the regularization algorithm. With the regularization algorithm, if you are able to overcome the overfitting issues, right? Or different techniques that you use it to overcome. There are different techniques are able to overcome the overfitting issues. Okay, so after applying all the things, let's say if your model accuracy is good, right? So with the trained model and test model, the accuracy is good, then you are good to go with deploy the model. Once you deploy the model, okay, so the users can consume that one. For example, we are deploying the model let's say model is the app. We deploy the model as part of an app, Uber app. So somebody, let's say you want to book a cab from, let's say one place A to place B you want to go. You book an cab. So the cab automatically predicts, depends on the product, the traffic condition, weather condition, and also depends on the distance. Right. So it estimates the cost, right? The price, estimate the price. So likewise, once you deploy the model on production, it can be used by people. But in the case of training the model, what we do is we use the historical data to train the model. Okay. Fine. This is the high level overview of the machine learning model. If you take a look at the internet, so you can see different website, the different the phases they use it. This is the common phase. For example, as for a train model, right? So here itself, there are multiple steps. Also, you need to you need to split the data and train and test data set, and then you use the training data set. And what you do is, as per before you train, you do feature scaling and feature encoding everything, and then you do it. But this is the and a high level, or it encompasses all the things, okay, into it. Okay, so the next thing is, see, other thing what we can say is, right, we evaluate the model, and then what we do is we have something like validation set. We use the validation data set to fine tune your hyperparameters. So they, include that as a separate phase. Okay, so as part of evaluating model itself, we take care of that one also. Okay, the hyperparameter tuning, everything we do it, and then we refit the model, and then we evaluate the model accuracy, and then if the model accuracy is good, and if the model can generalize very well, and if the variance is not high, then what we do is we deploy it in the production. This is pretty much about the machine learning lifecycle. See, what we did, we started with training the model, right, upfront. Training the model. In the case, I've used the linear regression demo, right? So in the case of linear regression demo, I've shown you how to load the data, and we did not do extensive data cleaning. We did not do extensive data analysis, exploratory data analysis. Okay, and also we did not do extensive feature selection. These three phases, I did feature selection and exploratory analysis. We just did it at a high level, right? So I have used sns.pairplot function. So that is more than sufficient for that given data set, because in that data set, we do not have many columns. The volume of data is also not so high. So, but what we do is usually we conduct extensive exploratory data analysis, and then we do extensive data pre-processing, because in the real-time scenario, the number of features are more, the volume of the data is also, more. So in that case, these steps, we spend more time, and feature selections, we spend some time. But importantly, the data pre-processing, we spend close to 50 to 55% of the time. Okay, the rest of the time, for example, 55 to 60% of the time we spend it here. And then what we do is what we do, and then only we spend remaining 40% to train and evaluate the model and the deploying the model, right? We spend only 40% effort. So with the 55 to 60% effort, we spend it in data pre-processing only. Okay. So this is pretty much about the machine learning end-to-end life cycle. Now, what we will do is we will, directly jump into exploring what is feature, or let's say, let's take a quick look at in each phase is what we do. Okay. So before I end this one,